Hello, my fourth graders from Tomahawk Elementary.
Hi, darlings at Leesville.
All right, so this video is just designed to help you guys out with the math packet, and this is just going to be like kind of part one from March 30th to April 3rd. And we also highly encourage you to do Dreambox at least 20 minutes a day.
You'll see that at the top of the packet, but also I encourage my darlings to do the most they can so that we can get more lessons in than Tomahawk. Um, Also, just like for the reading packets, if you saw that video, on Thursday, April 2nd, if you would like to participate and get feedback, take Thursday's lesson, which would be day 4. Have your parents just take a quick picture of your answer sheet, wherever you wrote your answers, and text it to us on Dojo or through email if you're still not connected on Dojo. Just send it to us that Thursday, April 2nd by 8 p.m. And then that night, Mr. Kramer and I will go through all the ones that we've received and check them, and we'll send them back to you with feedback no later than noon the next day, which would be Friday.
All right, and then for the rest of this video, we're just kind of going through days 1 through 5 for the math portion of the packet. And we encourage you to scroll through at the top right of the screen. You'll see what day each part is on, so you can kind of scroll and find what days you need help with.
We just tried to give a little bit more clarity, and for some things, just show some models to help you. So that's it from us. Enjoy the next 5 days of activities.
For day 1, we have some number line puzzles. They're very basic. Number 1 just has 2 times 4, and then we're trying to find the missing product on the bottom. And then later down the number line, you have some missing factors, and they give you the product. And then number 2, you just have completing the facts, and then number 3, you're just showing whether the equation is true in your math journal or on your paper.
For 4 and 5, you'll just read it and show how you solved it. The challenges are always a little bit more tricky. We still encourage you to try your best, read it, think through it, and like they encourage, show your thinking with numbers or sketches. Here's the second link for day 1.
There's there's some multiplication fact strategies. Again, real quick, number 5 just goes through what we just looked at on the other page. But the number 6 is kind of cool. It looks at a table, and they already give you in the directions for number 6, what we're working with for multiplication. So it's right there. And then you're just going to kind of plug that number in to either multiply or divide to find the correct numbers.
And then we have more word problems. Down here it can get a little tricky if you're thinking too hard about it. It's doubles plus 1. So for example, if you forgot 3 times 6, you could think, oh, I know that 2 times 6 is 12, and then I add another group of 6, so it's 18. If you don't actually have this printed out, you can just, observe the top and then go ahead and write your answers for 1 through 4. Number 1, we just want you to draw a model of 3 times 5 and 3 times 8, and then read the problems and solve.
For day 2, we have models for multiplication. At the top here, you're going to be writing your own multiplication stories, and they give you an example, 1 through 6. And then for 7 and 8, you're going to read those multiplication stories and answer them and show your thinking. So again, show with words, numbers, or pictures.
Not calculators. All right, the second link on day 2 is really thinking about what is going on. I like this because it's kind of like reading comprehension with math. Are you actually adding, subtracting, dividing, or multiplying? And that's true for nearly this whole page here. For some reason, there's a blank page in the middle. Even number 5 again. And then the directions change for 6 and 7. All right, we are modeling how to divide a 2-digit number by a 1-digit number right now. We both use the same acronym, dad, mom, sister, brother, which means divide, multiply, subtract, and bring.
Mine means bring up, and Mr. Kramer's means bring down. And hopefully you'll be able to see that it's essentially the same thing. So how I would set that up, I would put my 7 on the outside and my 89 on the inside. Okay. Start with Dad, divide. How many times can 7 go into 8? Once. Mom, multiply. 1 times 7 is 7. Sister, subtract. 8 minus 7 equals 1. Brother, bring. Then we start back over. Dad, divide. How many times can 7 go into 19? Only twice. Now Mom, multiply. 2 times 7 is 14. Sister, subtract. 19 minus 14 is 5. Brother, bring. Now I can see there's nothing left over here to keep working on, so that becomes my remainder. So 89 divided by 7 equals 12 with a remainder of 5. This time we're doing a 3-digit divided by a 1-digit. And I thought it'd be fun to write it as a fraction because we know that when something's written as a fraction, it also means divided by that much. So I would set it up, 3 on the outside and 187 on the inside. Okay, Dad, Mom, sister, brother. Dad, divide. How many times can 3 go into 1? It can't be done. So some of you might just move on over and make it an 18, or you can still go through the steps. Multiply, 0 times 3 is 0, sister, subtract, it is still 1, and then brother, bring it. Bring it, brother. All right, then start over. Divide. How many times can 3 go into 18? 6 times. Mom, multiply. 6 times 3 is 18. That's always fun. Sister, subtract. Brother, bring. How many, back to the beginning, how many times can 3 go into 7? Only twice. Mother, multiply. 2 times 3 is 6. Sister, subtract. 1. Brother, bring. And again, I can see there's nothing left here, so I have a remainder of 1. If this was a 0, then that would mean the remainder would be 0, also known as no remainder. It would just work out equally, right? So 187 thirds is 62, remainder 1, or 62 and 1/3.
The first link for day 3, these are both multi-step problems, so you'll need to be doing more than just dividing.
They're a little tricky, so make sure you're using those reading comprehension skills.
And then the challenge down here, it's also multi-step, but you'll see the divisor is going to be 12. In 4th grade, we typically don't use a 2-digit number for the divisor, so we just encourage you to count up by 12s if it's too challenging for you.
This is the second link for day 3. And it's dealing with division, and sometimes division has a remainder, but we need to know what to do with those remainders in real world situations, so this is kind of dealing with that.
So if you were dividing the number of balloons to make sure each table had the same amount, if you had extra balloons left over, so say the answer was 1, say there was 1 balloon left over, which it's not, you still have to figure it out, would you leave that 1 whole balloon? Would you cut that balloon into a fraction to divide it among the tables?
Nope.
Or would you cut that balloon and divide it into a decimal and divide it among the tables? And then C, explain why you chose your choice for letter B. Same thing down here for number 2, except this time you're using money. So Jeremy's dividing up his money. Say he had $1 left over. Can he leave that $1 and put it into 2 places? Can he cut that dollar into a fraction and put it into 2 places? Or can he cut that dollar into decimals and put it into 2 places and explain why you chose what you did? All right, and here's the first link for day 4. Remember in 4th grade how we take this mat, and this actually represents 1 whole, and the part that's shaded in is a fraction or a decimal of 1 whole part. So just say that I had, this shaded in right here and the rest was white. How many tenths are filled in? Well, if I look at it divided into 10 equal parts, I would have 2 tenths filled in. How many hundredths? Hundredths would be each individual square or each individual unit, and there would be 20 of them. If I wanted to show that as a fraction, it would be 2 tenths or 20 hundredths. And then I write it in the same form as a decimal, right? There were 0 wholes. How many tenths? 2. And I can write it again, 0 wholes. How many tenths? 2. How many hundredths left over? 0. Or I could look at it, as 20 hundredths.
So then number 2, you still have similar stuff going on, but as you can see in B, C, and D, we'll also have some with mixed numbers. All right, for number 3, we're going to locate each decimal on the number line. So for now, we'll give you an example of 0.03 or 3 hundredths and 3 tenths. All right, so for 3 hundredths, if we see this number line from 0 to 1, but each of these bigger ones are counted by tens, well then within that first tenth, 3 hundredths would be 1, 2, 3, it'd just be 3 out of the 100 to make 1 whole. So this is where 3 hundredths would be. But then if we look at 3 tenths, well, we'd say, oh, that's like 3 sets of 10. All right, or the third big chunk over. So you could say 1, 2, 3. That's 3 out of 10. So right there would be 3 tenths.
And don't forget, you can also look at it as, as 30 hundredths. So technically, you could count 1, 2, 3, 4, 5, all the way up to 30, and it's equivalent.
Okay.
And then at the bottom, you would write which one is greater and which one is less. And switch it around. When you click on the second link for day 4, you'll see it was maybe mislabeled. We'll go ahead and do it anyway. This is kind of fun with dates. You have 2 choices on how to solve this. It suggests you could use a labeled sketch of an open number line. So just a quick draw. Number line. So you could simply, draw 2012. If you jumped back 12 spaces to 2000, and then how do you get from 2000 to 1997? You would only jump back 3 spaces. No, these are not drawn proportionately, but then you can see when I add my 12 and my 3 together, it would equal 15. So Anna would be 15 years old.
Or you could just say 2012 minus 1997 to find the difference in those years. And you could say 2 minus 7 you can't do. So you go get one. That makes 0. And you could say 12 minus 7 is 5. And then you could say 0 minus 9 can't do that. So you're going to go all the way over and fix that while you're at it. And then make 10 minus 9 is 1. 9 minus 9 is 0. 1 minus 1 is 0, which also leaves you with 15.
And then down here at number 4, you'll notice as you keep going, number 4 uses the information from a previous answer. And it does that later on the page also.
So this is day 5. We're looking at a multiple wheel for the top. We drew an example in red here to show you how multiple wheels work. You just take the inside number in that bullseye part. For ours, we have tenths. And then you multiply it out by the next circle out. So you'd say 1/10 times 5, and then the answer would go on the outermost part. It would be 5/10 or 50 hundredths. Next one, we have tenths times what would give us 5 wholes. Well, you'd have to say like, that's like 10 dimes. You need 50 dimes to make $5.
And in the bottom, just read and solve. Don't forget that a prime number means a number that is not divisible. It doesn't have any other factors besides 1 and its own self.